Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead, and welcome to Schweitzer Drive. Ernest Hemingway once said, "The best way to find out if you can trust somebody is to trust them." But he didn't work in cybersecurity. On today's episode, we're going to explore the idea of trust, particularly as it applies to the electric power grid and industrial control systems. My guest today is Nick Seeley, Vice President of Infrastructure Defense at SEL. Nick leads the development and integration of cybersecurity services and solutions for both commercial and government application. He holds a Bachelor of Science in Electrical Engineering from the University of Akron. Can I say the, Nick? Is that okay?
You might offend the people from Ohio State, or
well,
the Ohio State, but sure, we'll go for it.
I don't want to confuse the university in case there's another Akron. Nick also has an MSc from the University of Idaho, holds multiple patents related to power systems, and he's been with SEL for 20 years. Hi, Nick, and thanks for taking the time to talk to me about trust.
Hi, Dave. Thanks.
This is going to be really interesting. This is I have a lot of thoughts about trust and what it means. You go on to just about any cybersecurity website or you read the news and there's this idea of zero trust. And I think, I know we're going to spend a lot of time talking about this concept of trust and zero trust. So in the past couple of years, the concept of zero trust has been gaining a lot of momentum. The White House included the strategy in the executive order on improving the nation's cybersecurity last May and recently announced that it would implement zero trust approach to bolster the government's cybersecurity. So to get us started, what is zero trust? And maybe go back a step even a little bit further and start with, what is trust?
So there's a lot of philosophical, any number of PhD theses and stuff like that talk about trust. But I'm gonna say in general, trust is the expectation that one will act in accordance with the desires of another in a particular situation at a particular time. And it's a binary. It is either you trust or you do not trust. Sometimes we talk about trust and we conflate what I would consider trust and trustworthiness. And those are I would describe them as two distinct concepts. And there's some philosophical rationale for why that is.
What is one absolute and one is a dependence, if you will, on a situation?
Yeah. So that's where I go back to that the idea of trust is binary. It is a decision. Either I trust or I do not. A lot of times when we talk about trust, we'll say something like, well, I trust that person. And I would say that's inaccurate. What you're talking about is like you find that person trustworthy. So in literature, in sociological literature or philosophical literature, what they say is that trust is generally a three-part process. A, trust B for C, right? So A, like me, I trust you. B, for a particular situation, C. And we can also talk about trust in terms of a lot of times trust is bound in time. Mm-hmm. Like I extend that trust and I extend it at a particular point in time. It's not in perpetuity, because that's generally not a good idea. And we can think about that, especially if we talk about cybersecurity, talk about cryptography, right? At some point, that crypto can be broken and will be broken. Right. The idea is that, the heat death of the solar system comes before somebody would actually be able to do that. But at some point that crypto can be broken. And then we can talk about quantum and stuff like that and how that may be accelerated. But you trust at a particular time and you know that trust is only going to be valid for a particular period of time. So A, trust B for C, and then I could say at time T. Right. Whereas trustworthiness is it's a spectrum, right? So when people evaluate whether or not to extend that trust, they're going to talk about, okay, I place this person on this trustworthiness scale. And it's probably not as academic as what I'm talking about, but we all do it, right? We decide to trust, and we decide to trust based on where somebody falls on that trustworthiness scale. And depending on, the decision, how the gravity of that particular decision, they will decide to trust somebody for a particular situation. So if you thought about it on a spectrum of 10 to minus 10, right? 10 is like I have, for this particular situation, I have absolute trust in this person. Like I can trust that this person is going to uphold essentially without any reservation. -10 is essentially distrust. It's not just no trust. It's distrust. Like, I think this person has malintent against me, or maybe even malevolence against me. So that would be the negative end of the scale. And 0 would be essentially ambivalent, right? So we place things on a trustworthiness scale. And then once we place them on that trustworthiness scale, then we can kind of think about, well, do I want to extend trust based on where they fall on the trustworthiness scale?
How much of that is maybe it's the person or the entity kind of thing? I like to simplify it. If I leave a cookie on the counter, right, the trustworthiness of the members in my family. Is my wife really trustworthy? She's probably not going to eat my cookie. My kids, I got probably a 50-50 chance, and my dogs, I got 0 chance, right? They are going to get up on the counter and eat it. So that's kind of my scale of trustworthiness, if you will. And it's
that's fair. Reminds me of the marshmallow test.
What's that?
You place a marshmallow, and you can find these videos all over YouTube. But you set a child alone, or maybe your dog, or maybe your kids, depending on whatever age they are. You place a cookie or marshmallow in front of them, and you tell them, "All right, you can eat that cookie now, or if you wait 15 minutes, I'll give you 2 cookies." Right. And then you walk out of the room, and, parents have like cameras set up so they can watch them remotely. And like the anguish and angst with which these kids like try to resist eating that cookie or that marshmallow is just, it's funny if you've never seen it before. Right. But yeah, it's kind of like, do you trust that person? And luckily in that particular situation, it's a marshmallow, it's a cookie, like it doesn't matter. But when you're talking about cybersecurity, that becomes very important. Like, what are you trusting, and why are you trusting it? But to be clear, the marshmallow experiment was not designed specifically to, answer questions about trust. It was really designed to answer questions about self-control, which is exactly why it's so funny to do that to 4-year-olds, because that's not exactly their forte.
Well, let's go on that. Now, actually, now I got something to watch tonight when I get home. Maybe I'll watch it with my kids, my dogs, and my wife to see where they fall on the spectrum of marshmallow trustworthiness. But how is zero trust, since we're going to that'll be pretty much the theme for our talk today, different than previous cybersecurity approaches? Yeah, a lot of what has been done previously. We talk about essentially defense in depth, and there's a lot of, I think, criticism of defense in depth, and maybe I would say maybe it's a little unfair. A lot of people say defense in depth is dead, but the idea is that you have layers of defense, right? So everything's not on a particular flat network where it's just like you access that network and you have access to everything. There's all, talks of like separation, segmentation, like putting firewalls where they need to be. And then I would say maybe some of the concerns that people have about defense in depth is that once you do kind of get past a particular layer, a lot of OT protocols, and I think the vast majority of OT protocols, they have no ability to authenticate. So once you get beyond that layer where you've got machine-to-machine communication, you can launch a message in that network, and there's really no authentication. So the machine that gets it or device that gets it has really no ability to say, yeah, I can trust it. I know it came from this particular device, and I should act on that command. So that's really kind of some of the challenges that we have with OT. Cybersecurity. So zero trust. The reason why zero trust, I think, has gained a lot of interest is, number one, it's kind of provocative, right? And you've got this idea of like, no, you can't trust anything, which we'll talk about that because that cannot possibly be true. But the idea is that you still have layers, right? But you're within those layers, you're doing things like encrypting basically everything, right? You are, authenticating everything. Like you're doing whatever you can to make sure that you are not implicitly trusting anything that's coming across that network. And that's really what zero trust is really trying to remove that implicit trust within the network. Trust is an essential part of being human. Just think about how many things and people you have to trust to get through an average day. The term zero trust implies a complete lack of trust based on what you just described. That's not really accurate. At some level, everything we do as individuals, organizations, or government, including cybersecurity, requires some level of trust. So can we eliminate trust and get to zero trust?
There's a German sociologist wrote a book called Trust and Power. His name's Nicholas Luhmann. I think that's how you pronounce his last name. But anyways, one of the things that he talks about is this idea of trust is a mechanism to reduce complexity. So if you think about that, the reason, and I think at least for me, it makes a lot of sense. The reason that oftentimes we extend trust is because if I don't extend trust, then I have to go through the process of figuring out, is this particular thing okay for me to use? If I just extend trust, I don't eliminate the complexity, because whatever the complexity of that particular object, it still exists, but I don't care about it anymore because I'm trusting it, right? So I just kind of offload that. But that complexity still exists. So you talk about just like your average everyday trust in life, right? You fly a lot. I fly a lot. I can't tell you what keeps an airplane up in the air, right? I mean, we can go back to like Bernoulli's equation or the Navier-Stokes equations, and there's kind of people talk about that of like how lift actually happens. And it sounds like there's still some debate, but we trust it. So I don't want to have to understand implicitly those equations and why they work. I want to walk on the airplane and I want to get on it. And there's good reasons for that, right? I mean, the airplanes are they're built by people that are good at building them. There's certifications, there's FAA, like there's all these things in place to allow us to actually be able to trust that. And we do, and that's a good thing. And we can talk about, any other thing we do, the buildings where we go into, the homes we live in, stuff like that. There's a tremendous amount of trust. But when we think about it, it always goes back to at some point you're trusting. So let's talk about zero trust. One of the tenets of zero trust is to try to eliminate implicit trust. Okay. One of the things that zero trust asks us to really embrace is this idea of encryption. Okay, so we implement zero trust, and the implication is that I trust that this data or I'm keeping this data confidential because I've encrypted it, right? So I'm not implicitly trusting that nobody's on the network, right? I don't have to implicitly trust that. I'm encrypting something so I don't have to worry about it. It's like, okay, so if I'm really eliminating implicit trust, then I have to understand the crypto algorithm behind that, right? Because
where do you stop then?
Yeah, where do you stop? So, and you know a lot about crypto, right? You've developed invented some of our crypto products. So you would be able to have that conversation. I do not, right? I mean, I could look at it, I could eventually learn, but I'm not going to do that. Okay. So yeah, let's take that a step further. So even if we understand crypto, we now have to trust that crypto can't be broken. Then we come up into a very, very difficult situation where we haven't actually formally proven that there's not an efficient algorithm to break crypto, right? So this gets back to something called the P versus NP, or P equals NP problem, right? When you talk about computational complexity, is that P is a set of problems that can be efficiently computed, right? And NP is a set of problems that, and this is roughly, very basic, high level description of it. NP cannot be have efficient algorithms to compute it. All of cryptography is based on the assumption that cryptography is an NP, right? It doesn't have an efficient algorithm, and NP exists outside of P, right? But that's not been proven, right? So there's actually what's called a Millennium Prize, $1 million prize out there. If anybody can prove that P is equal to NP or P is not equal to NP, like you've got $1 million on the line. You can, if you can do it. But right now we are trusting that P is not in, or NP is not in P, right? Because if it happens that there is an efficient algorithm that we just haven't found out yet, like all of crypto is gone. And that gets into quantum computing too. So, well,
two things. And I don't think I'm going to be watching the marshmallow video because I'm going to be working on this $1 million prize now, because I think I can figure it out. How hard could it be? And the second part of, I guess, my comment is this idea of zero trust versus, and then you start digging into it, talking about the computational validity of, say, a crypto algorithm or something like that. And I would probably make the argument that I accept the fact that crypto may or may not be broken, kind of thing, and accept that in my risk assessment of zero trust, right? So I think in my mind I could understand that it is vulnerable, and then get to a good place recognizing that to deal with trust or to not trust.
Yeah. And so what we're advocating as we're looking at this internally, what we're advocating is not, I don't want to get into the mindset of assuming zero trust, because I think if we assume zero trust, then what we're not doing is we're not recognizing what we're actually trusting, and we're missing that, right?
Yeah.
So instead, what we talk about doing is kind of recognizing that there is trust, but just like, what do I trust? Why do I trust it? And when couldn't I trust it anymore? So in that whole idea, and those are really easy questions to ask, but answering those that's hard, right? Because there's so many things that go into this idea of trust. So when we talk about like a particular product, right? And we don't, within cybersecurity, I like to identify and, admit that product, cybersecurity is not just that product, right? So cybersecurity is everything that went into that product. So when we look at trust, at least, the work that we do here at SEL is like, we're looking at, okay, how did I make that? Like, what was the R&D process behind that? Where's the secure coding practices? Where did I get those libraries, or did I write this myself? What does my build system look like? Then we can go into manufacturing. It's like, where am I getting those chips? Like, how is it being manufactured? Like, do I have control over those processes? Like, all of that has to be considered when we're talking about cybersecurity. And each one of those has like an area where I'm going to trust at a certain point, because I can't possibly know everything that goes into that entire ecosystem. So we just have to understand, like, where are we trusting, right? And just be very, very aware of that.
So I look at zero trust, and I get the idea, right? We should be cognizant of what data we're getting and how it got here and what have you, right? And be skeptical to some level of receiving it. I'm probably with you in the case. I don't know if you ever get to zero trust, because that's you pull on that thread, and where do you stop? The one that always bugs me, that always seems to be sidestepped when we talk about zero trust, is the idea of initial trust, because I think everything falls out from initial trust. If I can somehow establish this initial trust, then I think the zero trust problem gets really, really easier to solve, right? And I don't know why everybody avoids the initial trust, but how do you get to a zero trust if you can't establish initial trust?
Yeah, that's a really good point. I was watching a really interesting the video on YouTube that Microsoft put up, and they were talking about the Xbox gaming consoles, right? And it's like they're claiming, I'm guessing this is probably true, but that's probably the most hacked device in the history of man, right? People trying to get free games or have godlike powers in video games. I myself I'm not a gamer. Yeah, right. I'm not a gamer, but it was interesting. And one of the things that they said in that video was like, their initial trust, they trust the silicon of the CPU. Like, that's their initial trust, and everything else outside of that is kind of like they have to build that nothing else is trusted except that one thing.
Yeah.
So when we look at it, I don't know that we necessarily go back to the silicon, but we definitely, right? I mean, we've got a lot of mechanisms of figuring out, like, what do I actually trust, and then we build our kind of ecosystem around that. But yeah, I agree with you. Like, that idea of like, we have to have some. Where do we start, right?
Yeah.
And once we get there, we can kind of build out and kind of build our defenses from there.
How do we determine what or who to trust versus not to trust?
I think that should be another $1 million question, another Millennium Challenge. I think that comes largely to just kind of understanding. Well, let me go back to some of the I've read a lot about trust in more sociology and philosophy than I have ever in my entire life, like up to this point, like, kind of getting into this. But one of the things that sociologists talk about in terms of trust is like, within people, we evaluate people based on character and competence, right? That's kind of how we establish, should we trust somebody? That doesn't necessarily work all that well in cybersecurity, because a lot of times we're talking about devices, but I think it is applicable to manufacturers, right? Like the character and the competence of the manufacturer. Like, if you've got a device, where did it come from? Does that manufacturer know where their software came from? Like, was it manufactured in an environment that they control and things like that? So there's a lot of that goes back to some of these human elements, right? But there's also this idea of another gentleman wrote a book called trust and trustworthiness, he advocates for this idea of called encapsulated interests. And that just happens to, when you decide whether or not to trust or go to make that decision of whether or not to trust or not trust somebody, you have to evaluate what are the interests of the party that you are trusting, right? So I go back to, if I'm deciding whether or not to trust a particular device, I still remove myself and, ask myself, like, do I trust the people that made it, right? Because that's really probably more important than understanding, can I trust this particular chip or, this particular algorithm or something like that. It's like, at some point, somebody wrote some code and it went in here. And at some point, somebody made a decision to buy a chip that went in here. I think if we can get to the point where we're kind of evaluating and understand where the product came from, and the intentions behind the people, if not that that's even an easy thing to do, but the character intents of the people that made it, then to me that's a pretty solid way of kind of understanding, should I then trust that particular device? And again, I'm not saying that's easy to do with a lot of corporate electronics behemoths, but I know that that's one thing. Obviously, we take at SEL, we take a big interest in like understanding customers and in being available to them when they have questions. And part of that is obviously we want our folks, our customers and collaborators to trust us, right?
Well, let's ask that difficult question. If zero trust is all the rage these days, how difficult might it be for a company or an organization to implement? And maybe that's pretty wide open, right? I bet that the answer for, hey, I have a website, I'd love people to come, my level of or expectation of trust is probably pretty low, right? Expecting, because anybody could show up, versus perhaps two relays that are exchanging information that says, hey, trip the circuit breaker or don't trip the circuit breaker, right? That's probably a different example of what we'd expect from a zero trust solution. Yeah.
So that's a really good point, right? So when NIST, the NIST document that defines zero trust or kind of talks really detailed about zero trust and what it is, it's a NIST document, I think 800-207, right? And that document outlines like what is necessary for a zero trust implementation. And I believe that's what most people are really adopting and trying to look at. That document was largely created for the IT space, right? And there's some really significant differences between IT and OT, and there's a lot of discussion on that. So I won't rehash all those differences. But when we're looking at zero trust, one of the things that zero trust for OT systems, one of the things that I would say that we have to be careful of is on the IT side of things, things like determinism and availability are not, they're important, but they're not as important in an OT network where you're tripping something to protect something and save something for millions of dollars of damage, and you have to do it in milliseconds, right? That's really not.
Yeah, you don't care about Netflix buffering or something like that, where if you were
exactly.
buffering up messages to trip a circuit breaker in a handful of milliseconds, you'd be pretty upset about that.
Yeah, that's a bad, expensive day. So we have to be really careful, right, about the controls that we put, the zero trust controls that we put into place in the OT side of the system. So, for example, and this is interesting about the idea of zero trust, especially when you look at 800-207. Within the zero trust framework, NIST recommends, or I would say generally requires, implementers of zero trust to establish a trust algorithm, right? So even within the zero trust document, there is something called a trust algorithm that is used to essentially be the arbiter of what goes in and should that command or should that access be granted or something like that. So yes, the zero trust document requires that people implement a trust algorithm, which I found interesting. But what that's trying to do is like there has to be something that is deciding whether or not to allow this command, to allow this access, right? Where we get into challenges, or where I see potential challenges on the OT side of things, is so what is doing that, and what is the latency that is created with that trust algorithm, right? And what is the consequence of that? So I think that's where there's really not a great a great solution or a great framework that talks about zero trust within OT. I think the zero trust within IT is good and useful, and I think we would certainly put our weight behind it and say, yeah, this is where we want to go. OT, I think there's some things that still need to be considered, because if we are putting things in that are causing any sort of challenges with availability or determinism, we should really, really spend a lot of time thinking about that before we actually put it into place.
Probably the benefit we have in OT systems is they're well defined. They have a particular set of tasks that they're supposed to accomplish. Whereas I look at the OT side, it's the wild, wild west, right? You want things hopping on your networks, hopping off your networks, all kinds of different activities, from sending email, watching Netflix, all those other things. OT is completely different, right? It's purpose built, designed to do a handful of things. So you can certainly bound your problem. And if the information or whatever your trust scenario is doesn't fit within what you're trying to do, you can just automatically exclude it and not have to make, exceptions or considerations for something that perhaps is a little bit unexpected.
Yeah, I totally agree. I think the environment that we would, or the traffic within the environment of an OT system is pretty. We should be able to define that pretty well, right? There shouldn't be a whole lot of surprises of what's going on there. And with that's kind of one of those ideas of like, if we can define that, here's exactly what should be on this network, then that helps us maybe redefine what a trust algorithm would be, right? As long as we see like this traffic that we know of going through here, and that's fine. And if we see something else, like that would be, we should think twice about trusting that. So we've got some work to do to figure out exactly how to implement a zero trust within OT.
Nick, you've done a great job of describing zero trust and strategies around that. What do you see as the next step then in, say, the deployment of zero trust, or maybe it's some other form of trust? What are the problems we have to see? You talked about, determinisms are some of the challenges we have, certainly on the OT side versus the IT side. So how do you see this playing out in the next couple of years?
Yeah, that's a good question. So within the NIST 800-207 document, one of the things that they fully admit is that the application of zero trust is an iterative process, right? We've got to figure out what makes sense. So I think the first things that we need to think about is how do we make sure, like in our world, right? We're dealing with protection systems, right? How do we make sure that we implement something that we know we're not running the risk of blocking that trip command that's going to save, clear a bus so you don't have a substation fire or transformer fire or something like that. Like that's really where we need to go is continue to start to implement these controls, continue to drive, talk of technology into, encryption is good, right? But we have to understand where encryption applies, right? And doesn't necessarily need to be everywhere. At least we don't think. But where does it make sense to actually put encryption and start to define that? Like, where does authentication make sense? Like, when do we absolutely need authentication? I think we've got some of that to work out, and then understand what are the best technologies for driving that forward. And do those technologies exist, or do we have to invent those technologies? And that's really, I would say, the next steps for implementation of zero trust within the OT side of the house.
One of the assignments we gave you was to answer the question, what is inherently cyber secure? How does answering that question, what is inherently, which is Nick will probably get a PhD when he can finally answer that question. What is inherently cyber secure, and how does that then relate with perhaps zero trust?
Yeah, so we've been thinking about that a lot lately. So that the answer to that question, what is inherently safe cyber, One of the things that we have done as a team, several people at SEL, we've gone back and we've tried to understand first principles of cybersecurity, right? Like what are, I have a power system background, electrical engineering, right? Maxwell's equations basically the equations aren't the first principles necessarily, but the premise and the phenomena of what Maxwell's equations describe, that's a first principle. We don't have that for cybersecurity, right? So that's something that we spent quite a bit of time looking at.
F equals MA?
We do. We need our F equals MA, or, you spin a magnet, inside of a coil of wire and you get a voltage, right? I mean, that's really that's first principles, right? That I don't think that exists in cybersecurity. I'd be happy if, our listeners, if anybody thinks they have it, I would love to talk to them. A lot of people go to like the CIA triad. I would call them tenets, not really principles. But what we've come back to is there are two things having to do basically uncertainty is we can take things back to this idea of uncertainty, but out of uncertainty, you get things like trust and complexity. There's some work that we're doing in trying to understand, like really understanding the role that trust plays and the role that complexity plays. And complexity is almost a platitude these days, but there are formal definitions of complexity, right? You've got like computational complexity, algorithmic complexity, information complexity. Just a whole idea in like thermodynamics is entropy is complexity and things like that. So I do think there may be some physical basis for cybersecurity in terms of complexity, but we're really, and I'm really interested in focusing on like how does the impact of complexity, because we can't say we need to eliminate all complexity because cryptography is fundamentally based on making things as complex as possible, right? And we can't make everything as complex as possible because then it's basically intractable and not usable. So I do think, at least in the kind of the hardcore like research areas, like I do like that idea of just kind of understanding complexity. And I think the more we look at trust and complexity is going to get us back to understanding like how can we make something inherently cyber safe.
Well, we got a lot of work ahead of us when it comes to trust and zero trust and complexity and being cyber secure. Which means we're going to have you back on at some point to see where you got with answering what is inherently cyber secure.
I'll let you know when I solve it.
All right. Thanks, Nick. So next month, maybe? All right. So at some point, Nick, it's been great talking to you about trust. I can't believe a bunch of power engineers or hardware engineers could spend so much philosophical time thinking about trust. But thank you again. It was a great conversation.
No, thank you.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.